afternoon to everybody. Today I present what we call ecosystem at CSI Piemonte, and that for us is a new reference model for inventing and redesigning our information system that have a longer time. And of course, we use as a foundation some of the WSO2 technology. First of all, just a brief introduction of CSI Piemonte. It's a private company that is located in the northwest of Italy, close to the border to France and Switzerland. And we are a consortium of public administration locally in Piedmont. We have more than 100, sorry? Okay. We have more than 100 members, ranging from the local government at the regional level to the City Council of Turin, to the majority of health and local unit, the university, and the overall province in the regions. At the left side is our mission, so our objective is to build an integrated information system at regional level, covering all the business process and data and services that are shared by this municipality and these public entities. Of course, as you can understand, our main issue is to govern this complexity that ranges a lot of public domain, ranging from the agriculture to transportation, environment, up to health and welfare topics. And in this case, our role is a full service provider, so we range from the strategic support to development to operation. We have a data center, and where we operate all the systems that we build for our customer. And now I switch rapidly to the meeting with WSO2 technologies that started in 2010, when we decided to govern the complexity, introducing internally some ESB capability, in particular mediation, and having a registry for catalog of the services to have a right understanding of what are the services and how it can be exchanged. We put as a priority because it's one of our internal politics is to be an open source technology, but with a company that can give support in case we have to manage a service level agreement with our customers. What we look at for our complete or great level of standard, open architecture, because we don't like to lock it in any proprietary technology. And of course, in that period, we were also interested in the cloud orientation, and to have also a platform that can give us other functionality, not only ESB and registry. We started a software selection that was completed in 2011. At the end, we selected three open source products with support, and we did some use cases that practically allowed us to understand deeply the performance and the productivity of the tools. At the end, WSO2 was the winner of this selection, and we started the road to internal dissemination. We have about 300 developers that deal with different technologies. Major technology internally is Java, but we had a longer path to introduce the architecture of the WSO2, also the technicality.
So we decided to have a central competence center with some people that, with the support of WSO2, in some project, the quick start package, to deal with some complexity and peculiarity of the projects. And now we use some of the components of WSO2 platform, ESB and governance registry, data server service, BEM, of course, AP Manager, that is one of the core technologies that we use for implementing the ecosystem. And now we are moving also, are interested in evaluating the CEP stuff. Coming again to our asset, as you see, we have a long story, so we have a huge asset, both in infrastructure level, so a lot of physical server and a lot of virtual server. And of course, we have a lot of application, up to 1,700, coming from different fields. Some are custom applications, some are packages, some are applications that we have insourced from other public administration. So we have a huge heterogeneity in technology and in the way to interconnect the application. But we know that for us this is a value because interconnecting public entity with their process and where data can give to the citizen and to the company that are working in the territory much more advantage. We did to deal with the complexity. We started a sort of enterprise architecture mapping to understand the real situation at the technology, application, information, and business level. And then we came up with 2 points that we start to address. The first one is quite common in different enterprise, big enterprise. So what we call the point-to-point integration, that is a strong horizontal independence in between the application. And some applications are also from different domains. So there's a sort of spaghetti integration that is due to not governance or design. The other issue is what we call the vertical dependency. That is a lock-in with the component application, the middleware, and the shared infrastructure. So any times you have to move or patch an application or a middleware, you have an impact on all the other layers. So this complexity gives us a lot of difficulties, starting from impact for new to change in the change for new function and technology, lower agility and time to deliver. And sometimes it's impossible to manage the different differentiations of the software level agreements because all the things are quite interconnected. And of course, sometimes it's difficult to manage an incident and problems. So we started to redesign the system to address the new development, and also to implement the transition. So we have defined a reference model that we call the ecosystem, and we start with a multi-year program to manage the transition from the old legacy system to the new one. And of course, also trying to get some more new requirement for the business line, such as having a clear visibility of the full stack of cost, also to do chargeback for a customer, or to enable new business services, such as those related to the involvement of the citizen in the participation of the citizen, or to implement smart city project. 3 main streams of transformation. The cloud orientation that allowed us to decoupling application from the infrastructure,
are engineering of the application, moving to a federated architecture of autonomous systems, and systematic approach to automation end-to-end to have agility and rapidly time to market in delivery. So we move from the legacy system that is represented in this way to what we call the CSI ecosystem. So different information system clustered by domain with strong interoperability rules, so standard applied. And each information system are called island in our terminology. Every island can use a different technology, of course also WSO2, but it's not mandatory. The important thing is that to have to share common rules in the ecosystem. At the infrastructure level, we decided to use a cloud management platform. At the moment, we use the cloud management platform, but we are evaluating also cloud stack, and probably in the future OpenStack. Each island is implemented as a virtual data center for an organizational unit in the cloud. Now come again the WSO2 technology that is used to support this transformation, this implementation of the ecosystem. First of all, each island can be implemented with a bundle of WSO2 technology, such as ESB, application server, database server, BAM, to implement the business logic in the island. Secondly, and this is the core of the federation for us, it's probably the most important things in the ecosystem, is the IP manager that is the core for to govern the interoperability at the ecosystem level. Of course, you can imagine that it will take a lot of time to move application from the legacy system to the new one. So we use again the IP manager as a glue to the old system and new one. So every interconnection, every cooperation between an application in the legacy system have to be published and shared via IP manager. You use also IP manager to support the transition from one application to the ecosystem, because we decided as a policies that before moving the application to the new model, you have to publish the application. So you have to standardize documenting and metadata the application in the IP manager, and then move all the connections that have to pass through the IP manager. After that, you can start moving the application in the new cloud environment. And of course, the last point, we use IP manager to enable a new connection that coming from outside, for instance, from other companies that have to interoperate with the public administration or other ecosystem that are placed in maybe in other regions. IP manager is it's a critical point, of course. So we did a lot of work in infrastructure sizing, and we did the performance and stress tests, supported also by WSO2. And now we are using the 1.4 version of IP Manager, but we are moving to 1.6. And as you said before, all the technology, in particular WSO2 technology, are managed via automation. We use Chef to manage all the deployment of the artifact, and we published also the receipt on the public repository.
To summarize some benefits, of course, with the API Manager, we gain what we were looking for. That is a governance of interoperability and a standard way to interoperate between islands, and the possibility to have an effective reuse, because with the API Manager we get a catalog of all the reusable system at an ecosystem level, and a tracing of the subscribers, or the consumer of the application that consume the services, with all the stuff related to the access control, and the management of the subscription, also for metering and maybe do chargeback for the reuse. Some issue that some of them are probably covered by new version of API Manager. Anyway, we like to extend the definition of the metadata definition with some typical public use metadata semantic. Of course, we need to customize the workflow for publishing and subscribing the API. One of the things that we are working on in this moment is having the functionality to promote an API from the pre-production environment to the production environment. We have two different deployments for the pre-production development network and the production action. So we would like to move to promote the API easily without having to do raw copy of the metadata. And considering that the API Manager is a single point of failures and quite critical for our ecosystem, we are thinking about implementing the disaster recovery and maybe the business continuity in our secondary data center. Two brief detail of two islands that we have implemented. The first one is this was related to our solution for e-health that we call e-health book. It's a sort of personal clinical repository that allow the citizen, the patient, to have a summarized collection of every clinical event. The events are operated and managed in a local hospital or local health unit, but the system can allow the citizen to get all the information, to have all the history of all his clinical history, but also enable the doctors or the professionals, health professional, to have all the situation, all the status of clinical event when the doctor has to do a diagnosis. Of course, to implement this situation with the solution, we have to manage the HL7 protocol that is mandatory when you deal with health system. We worked with WSO2 to complete the HL7 adapter with the level of HL7 we need, and to implement also monitoring, advanced monitoring for tracing and completely the message that comes from the proprietary system to the central system. Just a brief description of the e-book system. The orange circle is an island, the central island at the regional level, where there is a global index of the clinical events. So and the blue one are the island that implement the local or hospital department. The big one is exploded, and we put WSO2 technologies to interconnect the department systems, such as the laboratory information system, radiologic information system, electronic medical records, and of course from different protocol. And we get at local level an index of these events. When a citizen or a health professional have to get the situation, it come across the WSO2 CEP manager and access the local unit system to get the personal information and collect all the stuff in a personal view that can be used to take decision. The other system that we implemented with WSO2 technology is a completely different scenario. It's related to our open data platform that we did for region of Piemonte, the first one in Italy. We started 4 years ago, implementing some basic issue about open data. So starting with simpling download of data set. And they moved to open data service and now to open data API. And of course, we have a portal and we have some sort of metadata search on the data. Also, this solution is implementing the new ecosystem. The open data system is an island, and through the AP manager can be accessed by different channels, also from other ecosystems. E015 is the name of ecosystem for the 2015 international event in Milan that adds implement an ecosystem. So we are interested in exchanging information with other ecosystems. And of course, we have implemented different protocols to access the API, from XML to JSON or some geographic for geolocalization protocol. We standardize the API with copying the SODA or Socrates SODA standard that is formatted in that way. And we use in this case some technology from WSO2, of course, starting from the bottom, data servers to access the data in our local hub, data hub, and converting it to HTML. Then we ask to ASB to do protocol transformation, and in case of RDF, so resource definition file, we use the governance registries to put the semantic notation and the linking stuff in the governance registries. So every data set is an RDF description in the governance registries. At the right time, the ESB asks the template, so the metadata definition, to prepare the response to the API manager. What's next? Of course, we are interested in the evolution of the WSO2 technology, starting also from the Stratos and the cloud orientation. But what we are working now at the moment is to open the ecosystem to other type of data, not only data coming from the operational system, but also from the outside, in particular from the Internet of Things. So we manage a territory, the Piemonte territory, so the territory can give us a lot of information coming from sensors, from video camera and so on. So we want to connect, integrate, interconnect all the stuff to share and mine all the data. So we are working now on CEP for dealing with real-time management, and of course we will need to move to big data hub implementation. Thank you very much. If you have a question. There's a handler.
First of all, thank you for the presentation. It was very interesting. I was wondering if you have set up something to track messages between islands because when you're crossing multiple islands, you might have to monitor the messages across the island, and it could be very difficult to correlate all the messages. So do you have something like this?
Sorry, could you repeat, because I didn't understand.
How do you correlate the message when you have to cross multiple islands?
Well, we do not correlate messages because our atomic call. So it's the messages, the business function, the island spawn, just an API that's not to be correlated with the other one.
But if you want to track some end-to-end monitoring between the requester from one island to the service provider from another one, can you achieve this?
No, not yet, no. No, we have not implemented this. Okay. No.
Hi, what was special about the HL7 format that meant you had to have a custom adapter rather than using an ESB transform?
We use a HL7 adapter coming from WSO2, and I don't remember really the version that implements, probably 2.5. That's it.
Any more questions?